So it's 2 minutes after the hour. We'll get started here. Good day, everyone. My name is Dan Corno. I'm the Value-Added Products Sales Manager for Aggregate Industries Mountain Region here in Denver. Thank you to everyone for joining us today. I hope you are staying healthy and safe during these times. Today, we're going to talk about high early strength concrete, how this technology can reduce the time that it takes to put concrete elements into service, and introduce you to our highly advanced early concrete rapid force. Understanding the technical aspects of and the placement do's and don'ts of high early strength concrete, we know will give your company a competitive advantage. For example, you'll have better control over the schedule of that project, and in some cases may even reduce the time to in-service concrete significantly. You can offer a time-reduced option to your customers to get their new concrete in service sooner. You can minimize the impact to a business that depends on the concrete paving being in service and available to traffic and parking. You can position your company for more time-critical projects by providing a solution to your customers that perhaps your competition does not offer. We want you to know that our team and your local sales representatives are here to help you and guide you through the process to get you what you need. A bit of housekeeping detail for today. At the bottom of the screen, there's a Q&A button. We'd love to get your questions. During the presentation, please click on that Q&A button and type in your question at any time. And we will answer those questions at the end of the presentation. I'd like to introduce you to our speaker for today, JP Thierry. Performance Director for Lafarge Holcim. He's been with the company in the USA for 4 years, and he oversees performance across our company's ready-mix footprint across the country. JP has spent much of his career in the concrete industry and has spent over a decade in concrete research and development. Some of his research subjects include fire resistance of ultra-high performance concrete, fiber concrete, shrinkage control, and modulus of elasticity and shrinkage. Thank you, JP.
Thanks, Dan. Good morning or afternoon to all of you, depending on where you are today. And we'll go through what Rapid Force is and what it can bring to you, and go through a few case studies as well to illustrate really what the product is about. So to begin with, and maybe you can hear it on my voice, fall is already there, at least for most of us, and winter is just around the corner. So it's really that time of the year again. We've got quite a few projects to wrap up, and 2020 had its fair share of delays. So really what today is about is completing jobs faster, catching up on delays that we may have had during the year, and really try to make the best out of and gain a couple of weeks on winter and before we can call it a year. Now, what is Rapid Force? Dan mentioned it. It's about high early strength, but it's really more than just high early strength. It's a range of concretes within which we can really play at will with what we want to do in terms of strength gain and at what pace the strength will ramp up. And it starts from 4 hours, where we could imagine to remove the formwork on a wall, really just 4 hours after batching, up to a more conventional solution around 2 days after batching. So that's really a complete range. And what makes it different from the conventional high-early concrete that we're all used to really is about what it's designed for. So if we look at what conventional high-early is, well, most of the time it's basically adding a set amount of accelerator, 1%, 2%. So it's basically taking an existing concrete and putting a fixed amount of chemicals. So at the end of the day, what the target is to fasten the setting time, but really not impacting the overall strength gain, or not looking at the level of strength we're achieving at a given point of time. And more often than not, it also comes with a requirement to put extra manpower to accommodate for the quicker set time and make sure that you finish it, before it gets harder. So that's really a basic way to do high-early, and it's more about setting that really strength. On the other end, rapid force is all about strength, and really the way we're designing these mixes and the reason why there is a range is because we design for a given level of strength at a given time. So it's not about making sure that the concrete sets faster. It's about achieving a level of performance at a given time. And that without hampering finishability and placement. So while we're achieving a certain level of strength at a given time, we're doing it also extending the workability so that you and your crews have the time to finish it properly without requiring extra people on the job site. And obviously, it's a contract between strength and time, so we have the ability to custom design it to the specific needs of your job site. Because, in some cases, 4 hours might be really critical. In some cases, 2 days is way more than enough. So it's really the ability to tweak it to the final needs that makes it special. So what is important to have in mind, knowing that before ordering? Again, Rapid Force is designed with you in mind first. So really for me, the critical question to ask first is time to serviceability important to you or your customer? So does time matter? And obviously what I mean by time is being able to be really quick. If the answer is no, then this is probably not the right product for the purpose. If the answer is yes, then it's important to know what the service requirement means. What level of strength do you need to achieve? At what time to really get the benefits out of it? And once you know that, our team locally will be here to help you to make the right recommendation in terms of mix and propose you the right mix for the application. So that will set the base and the scene. Now, when it comes to application, well, the best practices that you already know still apply in this case. If you're doing flat work, it's important to have a stable subgrade. If you're using a formwork, it's important that it's tight and stable. Obviously, if you're pouring material, again, for flat work outside, important to evaluate the weather conditions up front and plan accordingly. Finishing, fairly similar to what you're used to do, and basically the recommendation that you're used to for finishing still apply here. Now, what's important to, kind of avoid is to change completely the schedule, especially once you've started. Once everything is set and prepared, it's important to stick to the schedule. It's important to not do some last-minute changes in the middle of the pour, because you're at risk of then having to rush all over the place to make it work properly, because the workability is extended, but then once it starts, it starts. So you have to make sure that you stick to your plan. Otherwise, you would struggle to keep up with the open time. And while we can cover a wide range of slump for convenience, and depending on the application, targeting a too high slump might lead you to some constraints as well. So it's important to make sure that you target the right level of slump for the application. But beyond that, really no difference with conventional concrete. Now let's look at a few case studies that I think will illustrate pretty well what this concrete can do. We'll start in New Orleans, which is kind of contradictory to my first pitch around fall and winter being around the corner. New Orleans, the winter is pretty mild, but in this case, the city was facing a significant challenge with a big sinkhole in Canal Street, and that's a pretty busy area. So they gave a challenge to the contractor to repair and finish the work in less than 90 days, and they had to build some walls to reinforce the entire subbase and then cover it, etc. So that was quite an extensive amount of work. And they had to complete it within 90 days for the city to accept the plan. So we came up with RAPIDFORCE tweaked for the purpose. Again, they had 2 cast walls, etc. So what we did is we designed a concrete that was achieving the final strength in 24 hours, so that they could basically really not worry about the load-bearing capacity and move to the next steps really fast. And doing this, we've been able to complete the project in 39 days compared to the 90 days limit that the city gave initially. So you can imagine, how important it was for the city, but also for the businesses around this area to be able to open this street for traffic and generate again revenue, and also not end up with a huge traffic jams for a long period of time. Another example, probably a little bit more straightforward in how we can link time and value, and back to the question I was mentioning earlier, is time of essence for the end customer, and then what's the requirement. That's a project we did in Minnesota, and the gas station here needed to repair the lanes. And obviously, when you have to tear down the existing concrete and replace it with a new one, this means that this lane is closed for business. So if it's closed for business, this is obviously a drop in revenue for the owner of the gas station. And if he has to wait for 7 days to open it back to traffic, or even 2 days to open it back to traffic, that's obviously 2 days of lost revenue on that lane. So we came up with a solution together with a contractor to be able to open the lanes back to traffic in 24 hours. So minimal disruption, which of course leads to a way lower loss in revenue for the owner of the gas station. So it's really a win-win, able to complete the project faster for us and the contractor, right? But it's also a big saving for the owner of the gas station and the end user. So actually the biggest value is on the end user part of the deal. Another example here for a USPS distribution center in Maryland. They had to repave the front of the docks. And again, same thing here, right? You imagine all these docks lined up to load and unload the trucks. If you close one lane or 2 lanes or 3 lanes, obviously that puts a lot of pressure on the other ones to cope up with the traffic. So same thing here. We sat down with all the stakeholders, understood the requirements, and the requirement was to achieve 5,000 PSI in less than 24 hours. That's where the sweet spot was in terms of value, right? So time to complete the job and be able to reopen. So being able to basically reopen the next day was a big saver for USPS. So we designed the concrete 5,000 PSI 24 hour, while still providing 90 to 120 minute workability retention, again, to make sure that there was way enough time to place and finish the concrete properly without having to add like 20% extra manpower for that purpose, because that would kill the benefit on the contractor side. And when we looked at the overall project, we completed the project a month ahead of schedule, which again, I mean, imagine the benefit for USPS in terms of ability to, manage way more load compared to what they were initially thinking. So big relief for them in that case. The last one, this one is in Denver, Colorado. And kind of So that's a more office space example here. So that's repairing a traffic lane in front of an office. And you can imagine that if this is torn down, then obviously employees can't park in front of the office, which means that they would have to find parking space somewhere else, walk, etc. So in this case, really the benefit was to be able to reopen the parking spots on Monday, back on Monday. So we did the job over the weekend, and we designed a 24-hour mix for that purpose. What's interesting here is that it's a good example of blending technologies together. Not only did we allow the contractor to perform the job faster and open this lane back to traffic on the next Monday, but we combined it with microfibers to also ease the placement, get rid of the wire mesh, avoid rusting at the surface on the long run, and increase the durability of the slab. So at the end of the day, it's RapidForce is not, just an all set technology that we can't combine with something else. This job is a good example of our ability to combine several technologies together to make it really a time-saving and a money-saving solution for all the stakeholders involved in the job, the end user, the contractors as well. And that's it. That's really the gist of RapidForce. Thanks again for your time, and now we can maybe move to questions.
Very good. JP, actually I had a couple questions show up in the Q&A, and the first one is, how long do you consider delay in finishing? Is it hours or minutes?
So no, it won't be minutes, right? Especially if the question is around, changing your plan in the middle of the pour, we're not talking minutes here. Again, remember that we design it for 90 to 120 minutes open time for placement. We're talking about half an hour, an hour. If you end up creating a little bit of a change in the process, it's fairly easy to lose half an hour here and there, and then suddenly you're not at 120 minutes, you're 150. So you're way more at risk of getting a core joint. So that's why we're putting some emphasis here on sticking to the plan, making sure that, if you may think that you might have to change in the middle, it's important to prepare for it upfront and have a backup plan if need be. But definitely not minutes. Yeah.
Sounds good. Another one would be, have you used this with shotcrete at all? And I'm thinking she maybe meant, can you make a RapidForce brand of shotcrete, perhaps?
So RapidForce as such, not for shotcrete. Shotcrete is a different type of process, and fair enough, there is quite a bit of accelerator injected at the nozzle generally. So we've been doing some shotcrete on some jobs, but not specifically RapidForce designed for shotcrete. Here it's really about traditional concrete targeting a level of strength at a given time. So it's really for traditional structures.
Very good. And actually a third one came in that says, can you do a quick comparison between UHPC or ductile and this product?
So ductile would obviously gain a lot of strength in a short period of time. The applications would be different, right? I don't think ductile will be well suited for example, a driveway or the lane at a gas station or the front of the docks. It's really ductile is shining where you have ultra high strength requirements, where you have little to no space with reinforcement, and kind of super high-end repair jobs, or really, really thin and slender structures. We're really looking at really high strength, high elasticity, modulus of elasticity, low shrinkage, that type of thing where it's basically designed to be able to cope up with thinner sections, etc. Here, we're really looking at, hey, the traditional structure is basically working from an economic standpoint, and that's serving the purpose. But how can we reduce the impact of a repair or of building a new structure on the overall time frame of the project? So it's really kind of two different applications.
Thank you. And if we didn't answer that question well enough there, please get back with us and we'll try to get that squared away. Let's see, one more. What safety measures would you recommend for RapidForce compared to conventional?
What, sorry, Ben?
What safety measures would you recommend for RapidForce compared to conventional concrete?
That will be the same safety measures. Where really, it's really similar to conventional concrete. So the same PPEs, the same precautions would apply in this case. If you think of, if some of you attended the previous webinars on Agile Flow, we had some more precautions around the formwork, especially for big lifts. That's not the case here. We're not really going towards self-compacting, so we're more talking about slump concrete. So it's really the same as conventional.
Very good. Would you say this would be a good mix to use in a drive-through?
Absolutely. It's actually a good application, right? If you recall the gas station, a drive-through is even more critical because generally you don't have several lanes, right? You only have one. So if it requires 2, 3, 7 days to open it back to traffic, this means no drive-through for 2, 3, or 7 days. If you have the ability to open it the next day, that's obviously a lot of revenue for the owner, right? So it's obviously a very good application.
Okay, and what slump should I order? And if I place RapidForce at a higher slump, can I still expect high early strength and performance?
So the short answer is yes, but you remember we said be cautious, don't over slump it just for the sake of over slumping. We can bring it to a fairly fluid state, as I just mentioned, not to the self-compacting range though, because there is an impact in terms of setting time and strength gain if you want to really reach the self-compacting stage. But still, we can make it pretty fluid. The thing is, again, don't overshoot just for the sake of it, because the more you stretch it, the more challenging it gets, and it has to be justified, right? Because if it's more challenging, then obviously there will be some impact on the cost and the constraints around it. So it has to really serve a purpose to really push it to the limits in terms of slump. Now, we're not saying that it's it's a zero slump concrete either. Again, we can push it to a fairly fluid state and still achieve the strength.
Thank you. And would you say RapidForce could be approved for municipal and DOT projects?
Absolutely. We had it approved in several markets by DOTs. We even did some road repairs in some locations as an application to the 6 hours part of the range, because that's a good application when you really need to repair a small patch. Then you can open it back to traffic immediately. So yes, it can be approved. Now, generally what we're doing is that we tend to not share the mix design, simply because we consider this is our know-how and intellectual property. But it will never be a hindrance to getting a project done. So we had to, and we did it, we shared the mix designs, having some NDAs signed in some locations and for some specific projects to make sure that everybody was at ease with what we were doing and getting the mix approved for a given project. So yes, it's possible. We've done it.
Very good, thank you. And the final question, probably everybody wants to know, what does it cost?
And this one, so first, obviously, you can imagine from 4 hours to 2 days, there is quite a bit of a range. And really here, I think more than any other solution, it's really about figuring out what the benefits are, right? So at the end of the day, we want to make it cost effective, but we want to make it a cost effective solution. So, you could say, oh, the 4 hours is just crazy too expensive. Yeah, sure, but depends on the value that you're generating at the end of the day. Think of the gas station or a drive-through. If you're gaining like 5 days of revenue, honestly, the concrete won't matter that much to the end user. So there is value for all of us in there, and it's important to understand where the value is and whether it makes sense or not, right? So that we shoot for the right mix for the right application. That's really key here. So really the advice for me is get in touch with your sales representative. They will be able to help you frame what the best solution would be. And then we can look at the economics around it.
Thank you very much, JP. I want to thank you all very much for taking the time to join us today. For the best information on how RapidForce can help you reduce the time scheduled for concrete work, reach out to your local sales representative. They'll be happy to help you select the best product for your application. We appreciate your time and attention today. Please be safe and have a great day.